To determine the appropriate conductor size for a motor control center protected by a 300 amp overcurrent device, you need to consult the National Electrical Code, specifically Table 310.15b16. This table, formerly known as Table 310.16, provides the allowable ampacities of insulated conductors rated up to and including 2000 volts at different ambient temperatures and based on the number of current-carrying conductors in a raceway, cable, or earth. The ampacity of a conductor is the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Using Table 310.15b16 involves several steps. Firstly, identify the type of conductor insulation you plan to use, such as THHN, THHW, or XHHW. Each insulation type has a specific temperature rating, like 75 degrees Celsius or 90 degrees Celsius. This temperature rating is crucial because it dictates the maximum temperature the conductor can withstand under normal operating conditions. Secondly, determine the ambient temperature in the area where the conductors will be installed. The ambient temperature is the temperature of the surrounding environment, and it affects the conductor's ability to dissipate heat. Higher ambient temperatures reduce the conductor's ampacity. Thirdly, assess the number of current-carrying conductors that will be bundled together in a raceway, cable, or directly buried. When multiple current-carrying conductors are grouped together, they generate heat, which can raise the overall temperature and reduce the ampacity of each conductor. The NEC requires you to apply adjustment factors to the ampacity based on the number of current-carrying conductors. For example, if you have more than 3 current-carrying conductors in a raceway, you'll need to apply a dirting factor as specified in NEC Table 310.15 current. Fourthly, locate Table 310.15b16 in the National Electrical Code. The table is organized by conductor size in American wire gauge, AUG, or circular mils, KC mil, and insulation temperature rating. Find the column that corresponds to the temperature rating of your selected conductor insulation, typically 75 degrees Celsius or 90 degrees Celsius. Fifthly, read down the conductor size column until you find the ampacity that is equal to or greater than the 300 amp overcurrent device. Keep in mind that the overcurrent protection device is intended to protect the conductor from overheating and potential damage. The conductor must have an ampacity sufficient to handle the load current. Sixthly, if adjustment factors applied due to ambient temperature or the number of current-carrying conductors, you must apply these factors to the ampacity listed in Table 310.15b16. For example, if the table lists an ampacity of 310 amps for a particular conductor size at 75 degrees Celsius, and you have 4 current-carrying conductors in a raceway, you might need to apply a dirting factor of 80%. This would reduce the allowable ampacity to 248 amps, which is calculated by multiplying 310 amps by 0.8. In this case, you would need to select a larger conductor size with a higher ampacity to compensate for the dirting. Seventhly, consider any voltage drop requirements. Voltage drop occurs when electrical current flows through a conductor, causing a decrease in voltage along the length of the conductor. Excessive voltage drop can negatively impact the performance of electrical equipment. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. If voltage drop is a concern, you may need to select a larger conductor size to minimize the voltage drop. Eighthly, ensure that the conductor insulation is suitable for the environment in which it will be installed. Some insulation types are designed for dry locations only, while others are suitable for wet or damp locations. The NEC provides information on conductor insulation types and their applications. Ninthly, check the equipment termination temperature rating. Electrical equipment, such as circuit breakers, switches, and terminals, has a maximum temperature rating for the conductors that are connected to it. You must select conductors with a temperature rating that is compatible with the equipment termination temperature rating. Typically, equipment is rated for 60 degrees Celsius or 75 degrees Celsius terminations. Tenthly, comply with all other applicable NEC requirements, such as those related to conductor identification, marking, and installation. The NEC provides detailed requirements for electrical installations to ensure safety and compliance. For example, conductors must be properly identified with colored tape or markings, and they must be installed in accordance with the NEC requirements for raceways, cables, and other wiring methods. Let's consider an example. Suppose you are using THHN conductors with a 75 degrees Celsius temperature rating and an ambient temperature of 30 degrees Celsius. You have 3 current-carrying conductors in a raceway, and you need to determine the appropriate conductor size for a 300 amp overcurrent device. Referring to Table 310.15b16, you find that a 350 kc male THHN conductor with a 75 degrees Celsius temperature rating has an ampacity of 310 amps. Since 310 amps is greater than the 300 amp overcurrent device, a 350 kc mil conductor would appear to be suitable. However, you must also consider voltage drop. If the motor control center is located a significant distance from the power source, voltage drop may be a concern. In this case, you may need to select a larger conductor size, such as 400 kc mil or 500 kc mil, to minimize voltage drop. Ultimately, selecting the correct conductor size for a motor control center is a critical aspect of electrical design and installation. By carefully considering the factors discussed and consulting the NEC, you can ensure a safe and reliable electrical system. Remember that the NEC is updated regularly, so it is important to use the latest edition. Also, consult with a qualified electrical engineer or inspector if you have any questions or concerns. The information provided is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Always ensure compliance with all applicable codes and regulations.